non-Fregean logics. And I'm afraid that if I start to speak about the story, so I never will, I'll never ending talk. And this is what I am afraid for. So, сколько? Час?
Ну, мы ориентируемся на час, хорошо? Мало.
Да быстро. Ну ладно, будем быстро. Okay. Non-Fregean games. Conception of non-Fregean games was primarily introduced for inquiring the process of scientific discovery, when abductive inference were employed. But this appeared to be helpful also in considering an issue of contextuality in logics. And this conceptuality in deductive systems, now it's we can find in many papers. For example, a paper of Peter Axel in Russian translation. I don't know, Peter Axel, but that's maybe in Hungarian name.
Yes.
If in Hungarian, then it will be Peter Axel. He proposed, for example, this example this is an example of contextuality in deductive system, not an abductive system. In deductive system, his general propositional calculus. In his general propositional calculus, we have such an axiom where the C operator means some context, which in essence is a sentence which can which is consisted also between not only with which is constructed not only with the help of usual logical connectives, but also with an additional zero place connective star. And C from phi here means a sentence which we can obtain from C by replacing all occurrences of the star by our phi, by our formula. And the sense of this axiom is that identity of two proposition is involves the contextual equivalence. More interesting.
What exactly C stands for?
C from phi, yeah.
Context.
C is, yes, some context which is in essence is a proposition. A proposition. This is a case where I need C. For example, we have formula. For example, where we have such empty place, and we can replace this empty place with the formula C. This is, for example, in such a way. But you see, here in the left side we have only phi of psi, any C. So C plays the role of context. That phi is identity of phi of psi involves the equivalence of two contextual formula in the same context C.
So it's
say equivalent,
like
but taking the account, here is identity, here is equivalence.
Alright.
It's not the same. So identity decides the equivalence. And this is an example of such a calculus where we can take into account the conception of contextuality. But more interesting in this connection is the systems of so-called non-Fregean logics. Firstly was this non-Fregean logics. Firstly was introduced by Polish logician Roman Sushka in the 70s. It is a long story with Roman Sushka because his conception of non-Fregean logic were in a sense there were some mistakes in this logic, which allows to judge him in the trick that non-Fregean logic is simply the model logic on the mask. Later on, another Polish logician, Ryszard Wojcicki, proposed another. He criticized Roman Sushka and proposed another.
Нет, нет, подожди.
Чуть-чуть сидю, у меня есть это.
Подожди, ладно, рассказывай.
He criticized Roman Sushka and proposed another version of non-Fregean logic, which was free of those changes in modality. In the system of Ryszard Wojcicki, we have, for example, another this axiom of Peter Etzel. Maybe they have a parallel, but you see here is this identity of two variables, x and y. As this we have, if we here have equality, so here we have an identity.
These variables, are they sentential or no?
And now I need to deliver some comments about non-Fregean logic. I'm afraid that I need to do it. Firstly, because nobody here doesn't know what does it mean non-Fregean. Yeah? No one knows what is the name non-Fregean. Why non-Fregean logics? Yes?
What is Fregean logic?
Yes. The conception of Roman Sushka was firstly as such. He accused Frege in such a trick that in his, you know what Frege did to count the logical meaning of the sentences. If we take okay. You know, according to Frege, we have, for example, we have such a formula. You have a proposition. So, according to the semiotic triangle, we have his meaning. Так, reference. The reference. We have a reference.
Вот, я принесла.
There's a reference. And we have a sense. But what exactly connected with what we can exactly say about case where alpha is a proposition? For example, the snow is white. We can say that a reference of this alpha is some case of situation. It's a situation, and also we can say that this situation. And its situation also a reference in a sense, and Frege proposed that real meaning, a real reference, and the sense of the propositions is exactly the logical meaning. Logical meaning, which we can truth or falsity. Truth or falsity? Truthfulness and false. Truthfulness and false. And we have such, for example, the destroying this triangle, because in any case, when we speak about the meaning of our proposition, for example, the snow is white, you can always answer the question: is it true or not? It means that you know the situation, and everybody knows the situation when he told you that this is true. He knows about the situation on which I can ask him. So it's exactly enough, to not split, but exactly to destroy this triangle and leave only this logical meaning for propositions only. In this case, Sushko proposal concerning the system of logic where we split this logical meaning exactly to revitalize this triangle. And his proposal concerning the equivalence. He proposed that to extend our logical systems with usual connectives, with an independent connective identity. This connective identity. What is the difference? Because you know, as usual, we always can we call use a definition. Yes, I can use this definition of this kind. And Sushka propose to speak in this case of equivalence and not identity. This is equivalence. This is independence connectives, which connect exactly with notion of the situation. When he tried to formulate such a schematization of this logic, he found that semantics for these logics can be based on the Wittgenstein's Tractatus theory of situation and notion of the Wittgenstein situation. And this came when we consider alpha and beta, alpha equivalent to beta. Yes, then we have such an axiom. If alpha is identical with beta, then it tells that we have alpha is equivalent to beta, but equivalence is not identity. And he built some semantics, some situational semantics in logics, where this meaning of this connective was as follows: alpha is identity with beta. It means that the situation which is described by alpha is exactly the same situation which is described by beta. And for other usual logical connective, we also can give an interpretation of this connective in the situational terminology, but this connective will have exactly the same meaning. And this will be practically an extension of the usual system of logical system of propositional logic, classical propositional logics. The main fallacy of his system. And this he entitled his system as non-Fregean logic because of this additional connective identity, which is not usually figured in the system of usual propositional logics. It's non-Fregean because Frege told us that we can speak only on logical meaning of proposition, and according to Sushka, we can speak about the situation meaning of proposition. That instead of true or false, we can speak about facts. Are this proposition fact or no? And so alpha is identity with beta means that the situation for alpha is the same as the situation for beta. But his main mistake from the point of view of Richard Lukitsky was that he proposed some some axioms, for example, such that if proposed such mixture of logical and situational connectives. He proposed, for example, such connectives that alpha is connected with beta, yes, and the, for example, gamma. Gamma is identical with delta. Then it follows that alpha. And gamma is identical with beta and delta. Richard Lukitsky his point of view was worked in an opposite direction. He told that here we have a mixture. In such an axiom, we have a mixture of logical and situational connectives, and this axiom is not true because situations and algebra of situation and situational ontology is not the same as the logical. And he proposed such a system in which we have only axiom, which such kind of axioms in which we have not any mixture of this connective. In fact, here first proposal was exactly of such an axiom that alpha is identical with beta. This connective we can say co-referential. Alpha is co-referential with beta. They have the same situational reference. Alpha is referential to alpha. Yes, and then alpha if alpha is co-referential with beta, then we have that, for example, that gamma of alpha is co-referential with gamma of with beta. And exactly like in case of beta S. Okay? And finally, the last axiom is that identity, from identity it follows equivalence, but not the other way around, only in one direction. There's a situation undecided. They decide about of the logical mean, and not in both directions. This is to say ontologic is main, ontologic in main theory, not the logical. And so ontology dictates our logical laws. And you see there is any mixture of logical connective with situational connective. This was exactly proposal of Vasyukov. In the sequel, I will follow the line of Vasyukov and will use his version of non-Fregean logic. So you see now what does it mean, non-Fregean. This system with situational semantics, not with only truth and false semantics. So there are now some extension of non-Fregean logic. For example, first extension concerning introducing concerning the splitting of the Vasyukov connective. We can split it with such kind of situational implication. Implication, or we can read that alpha situation implicated. It means alpha referentially involves B. Alpha referentially involves B. So in such a system, for example, we also have such a kind of axioms. You see, but here we have two kinds of implication: situational implication, and usual implication. Another extension which I will exploit later.
May I just short remark before you are starting concerning Frege? Because actually for Frege, reference, not meaning but reference of proposition is truth value, not sense. But reference.
Yes, of course, but the main point is that for Frege there is, in case of proposition, there is any triangle.
Yes.
This is exactly the point. Because in the case of names, we have a triangle, but in case of proposition, we haven't any triangles. We speak about this.
But he says explicitly that it's reference. We are therefore driving into accepting the truth value of a sentence as constituting its reference.
And also with a sense, because in English meaning for linguists is the same. There is any difference between meaning is a reference and the sense. The sense is invention of Frege. Frege's invention of sense, exactly. But in case of proposition, he used such a trick that we haven't any triangle, have only one parameter, so to say. Another extension of metaphoric non-Fregean logic is connected with his triangles. That we can also, in a sense, we can try to exploit. To split exactly to triangle, not only to have references, but also for some identity or identity in a sense. And there we have, so it will be conceptual similarity by sense both proposition involves the sensual similarity. So, in a sense, if we have in a sense that B from I prime is in a sense is coreferential as B from I, then it entails that I in a sense is identical with coreferential with A, in a sense. Not only only like here it's coreferentiality. It's not coreferentiality, and the trick is the same. And because that we have the name non-Fregean. Non-Fregean because we for the second time used the trick of Sushko. So, for example, we can of course we can split this connectives, obtaining some kind of contextual situational implication. That in a sense, if it means that if alpha prime conceptually in a sense involves A, then A prime in a sense involves A. In a sense, not in all senses. It's not a referential, but in a sense. So we can, the first point is that in such system of such a kind, conceptual dependence determines logical. So maybe the first resume. But we can understand this determination in the Kant's notion of the equation of pure and applied logic. When applied logic, in our case, it's contextual logic as applied logic, and classical logic as a pure logic. Then we have Kant rules that contextual logic considered rules of the application of our reasoning, common sense, our common sense under subjective empirical conditions. It's exactly a common logic in that sense that it investigates the application of this common sense without any differentiality in objects.
Translation of Kant.
Sorry, I do not prepare the English version of Kant. So, and if we the next point will be that we if we try to understand how this contextuality works in such systems, we can understand it, for example, in the frameworks of the theoretic game semantics. Maybe maybe some will be such a tool for understanding what does it mean, this contextuality. Exactly. New, so to say, new color for this understanding. For this aim, we firstly recall the first notion of the game theoretical semantics in case of classical logics. This is exactly starting postulate that we with any sentence S from the first order language S, we can associate with this sentence a semantical game G from Sm, which will be played with S on the sum model M of the language in which S is formulated. That's what exactly means G from S and M. The notion of this game.
One thing I don't quite understand. So your semantic is game theoretic semantic, right?
Yes, it's a possibility.
But then
Basics of
just question terminology. But then you may say this game is model of your friends, right? But what does it mean that this game is played on your model M? What is
on some model.
But model which is not itself a game.
Yes, model is not a game. There is a connection. Later on I will explain this connection with models and games.
And what kind of model then if it's not a game?
Depends.
I will describe later on. I will describe this. In this case, a standard model for first order logical predicate logic. First order predicate logic. So this is a set with some universe set with some kind of relations on them.
The game doesn't concern the model.
Exactly, I'm just recalling the basics of this game theoretical semantics, because later on we will exactly explain this the role of M. So the second the game is played by two persons, which we can denote as me, myself, verificator, and nature, falsificator. During the game, myself trying to define truthfulness of some sentence, trying to verify it here. And the task of the nature is to refute it and finding that the sentence is false, falsification of the sentence. In any stage of this game, GSM layers consider sentences and some extension, L and C. Some extension, this extension of the language L, where this domain of M is in the region of individuals of M, which we obtain by adding new individual constant as a name for individuals in this domain for those individuals which previously had not any name. And now, the next stage is exactly the rules of this game. I hope somebody knows the rules of this game. So this is a classical. You see that, for example, the game in case of the disjunction, yes, in model N, it started with from the choice of myself E1 or E2 and the game, and then we have the continue, and then we proceed with the game G from S, I and M. In case of conjunction, we have the case where the nature choosing E1 or E2 and the game, and we proceeding in such a game. In case of existential quantifier, then we start from the choice of myself, some individual from our domain of our model, and for example, let his name be, for example, C. Then the game will continue as G from C0 from C. In case of this universal quantifier, we move in the same manner, but the choice is now the choice is now the privilege of the nature. In the case of negation, we have an exchanging of roles of nature and myself, and finally, in case of atomic formulas, then we have if S is atomic formula or identity, then in case when S is true in M, then myself is a winner, and if S is false in M, then the nature is a winner, not myself. So this is the usual statements of game theoretical semantics. So it's not the point of our interest. But now we have if we try to proceed in this direction, then the first proposal will be mainly, obviously, that we can, in a way, one or another way, to include these rules in our non-Fregean games, if we try to yield the semantics for non-Fregean logics. But here is the main trouble concerning that we in our semantic have not with the truth falsity. We are dealing with factuality and we are dealing with situations. So we need a good notion of situation, which will be good for formulating these rules for our game theoretical semantics for non-Fregean logics. And then we have that notion of semantics, which we will use this notion to Richard Luchinsky, are as follows: that sentences which are better interpreted in terms of situation, we can simply describe as a construction of the type A, phi A, where A small is the name of subject, A as sentence, and phi is an expression which connects first of them. For example, knows that, yes, afraid that, see that. For example, this transformation of the usual sense. For example, Pavel is a pianist. In the case situation of this, which is described by this sentence, is that this, we have two elements, to be pianist and piano. So then, for example, even in a performance is cancelled, can be transformed into situations. We have two elements, firstly cancelling something, and even into performance. So this exactly construction of the situation which we need. Another, more formally and logically, we can use set theoretical representation of situation, which associated with the sentences of the kind are I from A1, so I. So in this case, we have the common form will be such that we have I, comma, I1, comma, A, where all these elements are names in model for these elements of our language.
And R is just
You see this as you see this are exactly names in model for our elements of our language.
And R is a relation.
Yes, a relation name. Which are this or this? This is name.
The first
name for this relation. This is a name for this relation which we add to our model. We need to add such names to our model, if there are any such name. So you see here we have such R is the name of such R, respectively. If we have not such a name, a respective name, then we can say about the factuality of the situation non-I, and then all elements are the same. It's a negative situation, so to say. And we have not R, A1 and so on, but not R, A1 and so on. That's a negative situation. Of course, we also can say negative situations, not only positive or not only fast, but also have, for example, the snow is red. It is, so to say, false situation. Yes, it's not a fact. This is not true, so it's not a fact, not factual. It's a situation, but it's not a fact. And such an elementary situation, and in case of equality, we have such kind of situation, non-equality, such kind. Such elementary situation is take place or is a fact or is defined in model if and only if when we have, you see here is, so to say, this R and this R are different. So this is model name, for this name is true when we have that where this phrase, the expression of language will be satisfied in the model.
What does it mean to have a name for a relation? Name is just you have some coding of all relation.
If you have a model, yes, the model usually first order model is usually inside the universe, and we have also some names for R0 usually for equality, R1 we have and functional. So model always had some elements, but there will be a situation where, where for some relations in our language, we have not exactly this relations. So we need to add the names for that as an elements of our universe to extend our universe.
So they are not sets. They are not sets. Right?
About that I will say later on. Simply names. We need simply names. We need to add them to our model, to extend our model. In this case, because to formulate, there is a difference. This is expression of our language. This is expression of our semantics model. Situation is expression of our semantics. So we simply, for the simplicity, we use the same name, but only I can stress them, for example, with another type. So.